Hi, my name is Doug Tuga. I'm the Department Chair of Electrical and Computer Engineering here at Valpo University. I'm sorry you can't have a tour of our building in person, but I'm going to try to give you an electronic tour that'll be almost as good. We're here in Gellerson Engineering and Mathematics. This is a building that we share between the College of Engineering, the Department of Computer Information Sciences, and the Department of Math and Statistics. Having this building where we share all of those resources really gives us a great opportunity to coordinate with the faculty from those departments, make sure that you have the best education that you possibly can. We have lots of student organizations here in the College of Engineering. We have 14 different organizations that you can belong to, and all of those student organizations give you lots of opportunities for learning about technical skills, professional skills, social skills. These are all things that those student organizations can give you. We have student organizations that are focused on your disciplines, student organizations that are focused on helping support women in engineering, National Society of Black Engineers, Society of Hispanic Professional Engineers, and so forth. Over here, this is the Hesi Learning Center. The Hesi Learning Center gives us an opportunity for students who maybe need a little bit of extra help in that first semester or in that first year. I went to a really small high school when I was a student, and when I arrived at college, I still had a lot of things that I needed to learn. I really wish that an opportunity like the Hesi Center had existed at my college, because I think it would have made a big difference for me. We try to make sure that we provide students with that level of support, that level of help, because we think that every student who gets admitted into the College of Engineering can succeed, and we want to help make every possible chance for them to succeed. The Hesi Center is just one way for us to do that. We give scholarships to some of our very best students, and then in exchange for those scholarships, they provide service back to the university in the form of peer tutoring. So if I'm teaching a student and they're anxious about coming to my office, no matter how friendly I am, or no matter how much candy I put out, they won't come to my office hours, but they will come and they will talk to a classmate. They'll talk to somebody who got an A in the class last year or the year before, or somebody who's sitting next to them in the class this year. And this gives them the help that they need to really overcome any obstacles and get back on track so that they're going to be definitely successful as a student in the College of Engineering. I wanted to show you one of our classrooms. Over here we have, this is one of our largest classrooms in the building. So this is definitely not a typical classroom, but it really is nice to be able to see the sort of classroom where you might have an opportunity to learn as a student. Our typical classes here are going to have about 20 to 30 students in them, leaning more toward the 20 side, but if we got to 32 students, I would definitely want to double section that course. So you can count on a close interaction between the faculty and the students. That's really one of the characteristics of a Valpo education, is that the faculty really love working with the students, and you can count on having a close personal interaction between the faculty and the students here at Valpo. We're going to head back toward the engineering labs here. In this part of the building, we have lots of laboratories. There is a second floor to Gellerson, but the second floor is really boring. It just has faculty offices and more classrooms, so we're not going to go up to the second floor. As we're going back to the labs, though, I wanted to take a minute and just talk to you about our international programs. We have opportunities for students to travel abroad to do their international engineering education programs in China and France and Spain and Germany. So you can spend time in your junior year, it would be your fourth year. You're going to take your 4 years of college, you're going to stretch it out to 5 years, and in that fourth year, you're going to spend a semester studying abroad, and you're going to spend a semester working for a foreign company. So you'll be in a co-op, you'll be in an internship position working for a company in Germany, in Spain, in France, and so forth. So it really gives those students a great opportunity to learn while they're also studying abroad. So now we're kind of at the intersection of all of Gellerson. This is the hub, and so we're going to head down toward electrical and computer engineering, which is my area of expertise. Hopefully you'll find that the explanation is excellent in that area. Here we have some posters. These posters are from our senior design projects. Every year we have senior designs where students are going to work in a team of maybe 5 or 6 students, multidisciplinary teams typically, and they'll be working for an external customer. So it's not a pretend project, it's a real project. A real project where there's a customer who's going to want to be using the result of that work. And so you can see that the projects are really exciting, and the students really enjoy working on those projects. They always report that it's too much work for the amount of credit that they receive, but then when they come back, they always say it was well worth the extra time. So here we are in the electrical and computer engineering wing. I just wanted to first of all take you into the visualization lab. So we have, this is our scientific visualization space. Let me turn on the lights here. Come on in. So the Scientific Visualization Lab has 3 giant walls. So there's the 2 side walls, the back wall, and the floor, all of which have 3-dimensional projectors built into them. So you can have 3-dimensional images, and we use the computers to stitch the images together in such a way that they really look as though they're coming straight at you. And this of course could be for entertainment, but for our purposes it's for understanding how students learn. So for example, we can give students these 3-dimensional glasses. They put on the 3-dimensional glasses, and it has these reflective spheres, so the cameras around the perimeter of the room can track where your head is located, and the computer will calculate how the image should look to your head. And then you have a little controller, you can adjust the image, and we can do computer-aided design, we can do electromagnetic field theory, we can do molecular analysis, all different things that can be projected onto this screen. And we can also have students who write those programs to be able to help other students visualize those things. This is probably our most important electrical and computer engineering lab. We have 3 main spaces in our department, and this is one where students are going to tend to learn a lot of analog circuit design. So they're going to learn how to use the equipment at each one of these stations to be able to solve various types of electrical circuit problems, and then they can actually build the circuits, and then they can actually experiment and find the results of measuring those devices. I mentioned to you earlier that one really important characteristic of a Valpo education is close personal interaction with faculty. But another one is that you're going to find that a Valpo education is going to be very hands-on. About half of our time as faculty is spent in laboratories rather than in lectures. So using equipment like this, we're going to have function generators, multimeters, power supplies, and oscilloscopes, as well as computer-aided data acquisition built into all of our computers. It's going to give our students the opportunity to learn this cutting-edge equipment, this really these brand new devices, so that when they come out, when they graduate and they go to work in industry, they're going to learn how to use, they're already going to know how to use this state-of-the-art equipment. So this is really important to us, that our students have a very hands-on, very practical education that will accompany their theoretical experimentation as well. Let's go to another lab. This one is primarily the digital lab. So this room really gives our students an opportunity to start with a very small, very simple digital logic device, AND gates, OR gates, and inverters, and work our way all the way up to computer architectures. So we're designing entire computer systems, but based on the same expertise they have of these original individual digital logic gates. The equipment probably looks very similar, and in some ways it is very similar, but the focus of this lab really is more on the digital side, so that the students are going to have an opportunity to learn programming, digital signal processing. They'll learn how to do digital logic design. All of that will happen in this lab right here. We'll go to our 3rd lab right now. And this is our junior lab. This is where we spend most of our time with our junior students. They'll be studying electronics, so transistors and diodes, and they'll also be studying the effect of some of building some of the equipment that they've already been talking about. So electronics is going to be one of the most important things that they'll study in this lab, but some other more advanced topics in here as well. Between sections of our classes, students can also spend time in this lab doing their homework and solving problems that they've been assigned by their professors. Let's look at a couple of undergraduate research labs. Undergraduate research really gives our students an opportunity to tackle interesting cutting-edge problems. Here we have, this is Professor Dan White, and this is his research lab. Professor White's research is in wireless communications, antenna design, and then he also does a lot of work with satellite communications. And so if you like communications and wireless and satellites, this could be the lab where you might want to work. There's another lab right next door. And this one is where our other faculty research projects happen. I should tell you that undergraduate research is really important to us. We don't have graduate students here at Valpo. So the faculty who want to maintain their current knowledge of the field and be cutting edge, they want to continue to do research, but the only way they can do that is with undergraduate students. So my research in nanotechnology, I'll find really promising sophomores and juniors. We'll start working on a project, and then by their senior year, we'll co-publish a paper, so that we'll be co-authors on a paper, and then that helps be a very valuable credential to them as they're preparing to go into graduate school. Some of the research projects in this room, we have more virtual reality, we have power systems, but the one that I wanted to show you in particular is we have a professor whose expertise is really in robotics and machine learning. And so this is the station where he does some of his work. One of his research projects is in swarm robotics, and if you look down here, you can see we have all of these small robots, and those small robots can solve problems together. So they work together to solve problems. We program them by beaming a program into the top of the robot using the little programmer there, and then they work together to solve a problem. They have to communicate to each other and figure out how to work together to solve the interesting problem. So that's a summary of our electrical and computer engineering labs, and now I'm going to hand you off to my colleague Dan Blood to talk about mechanical and bioengineering.
Hello, I'm Professor Daniel Blood, and this is the manufacturing lab. So I'm part of the mechanical engineering and bioengineering department, and your first semester, your sophomore year, you would have a chance to take the Intro to Manufacturing lab. And so this is a course where you learn how to use the manual mills, the manual lathes, we do some sheet metal work as well, and the idea isn't so much to turn you into a machinist. The idea is more that if you're going to design components, you need to understand how they're going to be manufactured after you design them. And so we walk you through this and understand how we can use the different pieces of equipment, some of the limitations, and some of the things you might want to consider when you're manufacturing those components later on. Now, another thing you get access to in that sophomore level course is the CNC Lathe and the CNC mills and our Cnc Plasma Cutter in the back. And so this is more of the newer technologies. So a lot of things are moving towards automation these days. And even though the manual equipment isn't automated, you're the one turning the knobs, it's still important to understand how that works. But we also want to give you exposure to this CNC equipment where we know how it can automatically turn all the knobs for you. So you're not the one that's actually moving the machine around, you're just the one that's programming it. Now you have the option when you're a junior or senior where you can learn how to use these machines more in depth. So we have electives that you can take, and one of them is the Advanced Manufacturing Lab. In this lab, you learn more in depth on how you can personally program the lathe, the mills, the plasma cutters. We talk about laser engravers, our different kind of 3D printers, and that's all things that we'll show you here in just a little bit. But the idea behind this whole lab is to give you the skill sets you need so when you go out into industry that you can be really productive and you can help out whatever company it is that you're working for. So next today, I'm going to show you our GE100 lab. So your first semester you're here, we want to make sure that you're not going to waste time at Valpo. So we want to get you into the right major right from the get-go. And one way we do that is our GE100 course, and that's our Intro to Engineering course where you learn how to do things hands-on. So you have some labs, you work in groups, and the main idea behind it is just understand what are the different majors for engineering, and then which one do you want to go into. We don't want you to have to go more time at Valpo than you really need to. We want to get you out in 4 years. That's one of our big goals. That way you can go out and you can start making money and you can start enjoying yourself in either industry, or if you decide to go on to grad school, you can do that as well. Now, the next lab I'm going to show you is a newer generation lab. So the manufacturing equipment that I showed you in the first lab, that's stuff that's been around for quite a long time, over 100 years. And the materials that are in here, this is more of our rapid prototyping. So these are tools that have really only been around for the past about 30 years or so. So over here on our right-hand side, we have our 3D printers, and these are our custom printers. We call these our spider deltas. So we used to use some commercial 3D printers, and we found out that even though they work okay, they didn't quite get everything done that we wanted them to do. And so instead of having to try to buy those and modify them, we just decided that we take some students and we work with them to build our own. And so these are printers that are all designed from scratch. And so we're the ones that are able to put it together, and the students, they're able to come in here, learn how to maintain it, how to optimize it, all the real fun things that go along with engineering. And so we can make anything from fun little trinkets, like some students will print off little fun items that they're going to take home either for a gift or just for their own dorm, or even things that are going to be more functional. So this is a hand from the Enable project, and this is about a $20 prosthetic hand. So usually the real prosthetics that you can buy are, let's say, $20,000 plus, very, very expensive. And if you're in a developing country where you're making on average $300 or $400 a year, it's kind of hard to buy a $20,000 prosthetic. So this idea is that we're going to take something, even though it's not quite as fancy, it's still very functional. And so this is a 3D printed prosthetic hand that someone can put their residual palm into, so they slide it in like this. When they flex their wrist, it closes the hand down and grabs stuff. Now, we have our research here where we're looking at the different kinds of plastics we can print with. And this is a roll of filament. So this is the material you use to make stuff. And with this particular technology, we can choose different types of filament. And the filament they suggested originally was breaking, when we did our testing, it would break where it only took about 20 pounds of the fingertips to break off the fingers. Which if you can imagine a little kid, they're very likely going to break off those fingers if that's all it takes. And so we were able to work with different materials and figure out how we can make this stronger. And now these can survive up to about 95 pounds. So much, much stronger. And we always joke that I'm pretty sure if putting 95 pounds at the end of your fingertips, it's going to hurt a lot more with the real hand than with something like this. Now, if you want to use something else, we have the ability to print with multiple colors or materials. And so we're working with, right now, trying to make things that have very unique properties where certain parts of the print are very flexible and certain parts of the print are very rigid. And that can create some really unique properties for the design side. We have the ability to print with our resin printer over there. That's the one with the orange cover on top of it. And it can do anything from very, very high detailed prints to more flexible, and we're even working with ceramics now. And then the one on the left there, the silver one, the Markforged, that one allows us to do printing with continuous carbon fiber or fiberglass. And so we can make prints that have the rigidity of aluminum, even though they're just 3D printed parts. And then lastly, we have our CO2 laser over here. This is one that we can cut wood with, acrylic, more of the organic materials. And in the back over there, we have our yellow fiber laser. And this is one where we can go ahead and start engraving metals. And we can even do things like making circuit boards. So this is an example of a circuit board that we cut on the laser. This took about an hour or so. And the great thing is, instead of me having to wait weeks for me to get a new circuit board if I'm prototyping something, I can come in here and within a matter of an hour or two, I can have a functional circuit board, and this only costs like 25 cents. So we can make a whole bunch of them if we need to. And so this is a really nice tool for students to be able to go ahead and do some prototyping. Now, the last thing I'm going to show you today is the Mechatronics Lab. So Mechatronics is a combination of mechanical and electrical systems. And it's something that's growing more and more. With automation becoming so important nowadays, you really have to know how you combine these two systems together. And this is the current Mechatronics Lab. Now, in the summer of 2020, this will be renovated, and it will be completely renovated to update things for the new Mechatronics minor. So if that's something you're interested in doing, we do offer a minor now where you can learn how things like PLCs, which are kind of like fancy little controllers, we can learn about microcontrollers, how we can do sensing systems, vision systems. There's a whole bunch of really neat things that go along with that. So if you're interested in something like that, I hope that you come and you can check out these new labs, and after the summer of 2020, this will probably look completely different. So I hope you look forward to seeing that.
Hello, I'm Dr. Carmine Polito, and I'm a civil engineering professor here at Valpo University. And I thought what we would do today is take a look at some of the facilities we have and talk a little about what civil engineers do. We're currently in the Soil Mechanics Lab, or as I like to call it, my lab. As civil engineers, what we're really concerned about when it comes to soil is three things. How strong is it? How much does it compress? And those two really control what a foundation for a building is going to look like. The third thing we worry about is how easy or hard is it to get water through. If you're going to put a well in, you want soil that's easy to get water through. If you're going to put a dam up, you want it hard to get water through that. This is also where I do my research. I research how soils behave during earthquakes. And you may have heard the word liquefaction. They sort of lose their strength during an earthquake. And that's what I research. And I love to get my undergraduate students involved with that. So why don't we take a stroll over across the hallway to the environmental lab, and we'll talk about what environmental engineers do. Welcome to the environmental lab. It underwent a major renovation last summer, in part to prepare it for our new environmental engineering major, which started this fall, and we're very, very excited about it. Environmental engineering involves a really wide range of topics. It can be anywhere from maybe what you immediately think of would be hazardous waste cleanup, and that's certainly an aspect of it. But other things include drinking water supply. The water comes into your house. Wastewater treatment. What happens to the water after it leaves your house? All sorts of those things are really important. And as the world progresses and there are more and more people, the environment becomes more and more threatened, and we have to work harder and harder to keep it safe. So we're going to step next door to the Student Projects Lab. This is the Student Projects Lab, which is due for a good cleanup any day now. We've dedicated this space specifically for our student organizations to work on various and sundry projects. You may have heard about our robot football team. Well, this is where all the robots get built. Other groups do other projects in here, and it's really great that they have a place to keep their stuff, where they can work as groups and interact for those sorts of things. So now we're going to go a little farther down the hall to the Transportation Lab. So let's go. Welcome to the Transportation Lab. This is actually a full-size traffic signal. So either traffic signals are bigger than you thought or are much smaller than you thought, one of the two. And behind it we actually have a controller. So if we were at an intersection, this computer work behind us would be the thing controlling when you get a green light, when you get a red light. And when we think of transportation engineering, I think we tend to think of roads, because that's most of our transportation interactions. But it includes a lot of other things. Obviously, buses, any kind of public transport, trains, airplanes, all fall under transportation. Airports, port facilities for boats. But also, traffic engineers are very often involved in land use planning. Things like, where's the best place to build a new shopping center, and how is that going to impact life in the community in terms of trying to get from point A to point B. So that's a little about transportation engineering. And now we're going to wander across the building and go and see the Materials Lab. Welcome to the Materials and Structural Engineering Suite, or as we usually call it, the Busting Lab. Why do we call it the Busting Lab? Because we bust things here. If you're going to be an engineer and you're building buildings out of steel and concrete, it's really important to understand how steel and concrete work. And so what we'll do is we'll take specimens of them, and then we break them in a machine such as this. We may use to pull steel specimens apart and look at the load versus the deformation and learn about the properties that way. Materials engineers deal with, as you may have guessed, materials. Very often the mixed design of a concrete, what goes into the concrete. Asphalt is another common thing they deal with. And now they deal with much more complex materials, things like polymers and composites. Structural engineers deal with buildings and bridges. I think when most people think of civil engineering, they think of structural engineering. And really, the beautiful bridges you see are built by structural engineers, but so are the buildings you live in. One of the research topics we have going in civil engineering that's being done in conjunction with our mechanical engineering department is the concrete printer. You may well have seen three-dimensional printers at your school where you can print small plastic parts. Well, this device will allow us to print things out of concrete with possible uses as design elements or even eventually full structures. So let's meander out of the lab here and take a quick look at this area that we're coming up to, the senior design space. Now, if you ask any engineer and they're honest with you what their first day was like, they will tell you, I had no idea what I was supposed to do. We've decided a way around that is that your first day at work is going to be, you get put in a group, you get put in a cubicle, you get put on a project, and they say, go. So for our senior design, which is the culminating experience of your career here at Valpo, is we're going to take you, we're going to put you in a group, we're going to put you in a cubicle, we're going to give you a project, and say, do it. We'd much rather you go through that first little struggle while we're here to sort of nudge you along. So you'll be a lot more prepared than if you hadn't gone through it. And so we are going to now proceed into what I would call the fluids lab. It's a shared lab with the mechanical engineers and the civil engineers. In civil engineering, when we talk about fluids, we're really concerned about water. Anything from this lovely model here, which is a groundwater model. We put water on one end, it flows through to the other. And you can think about that as being either a water problem or a soils problem. It works both ways. But we also have to think about things, what happens when it rains? If you build a giant parking lot, well, all the water that falls in that parking lot is not going to soak in the ground. It's going to run off somewhere. Well, you can't just let it run off onto your neighbor's property. They don't like that much. And so we have to find ways to route that water, to store it either permanently or temporarily. And so that's part of what we do. And we call that storm system management. But we also look at how much do we think it's going to rain? How big an area is going to be affected? And those are the sorts of things that you might do if you go into water resources in civil engineering. That brings you to the end of this tour. I hope you've learned a little about our facilities and a little about civil engineering. And hopefully when the world cleans up and gets healthy again, you can come by for a regular tour. Thank you for your time today. I hope you enjoyed it.